Hi everyone, in this video I'll be covering chapter 8, worksheet 2. So we'll be looking at trigonometric ratios, the applications of trigo ratios. So what this means is that in worksheet 1, you have learned what are trigo ratios and how to apply them. In this worksheet, you will learn how do I apply them in real world context, meaning that if now I have a word problem, how do I simplify it to simple triangles like what you have seen in worksheet 1, then apply these trigo ratios to solve different problems. Okay, so let's now look at example this portion over here. So let's do a bit of recap first. In worksheet 1, you learn a very important acronym. This acronym called TWA, KA, SO. So these are very important acronyms you must remember. TWA stands for tangent. Tangent of any angle is opposite length over adjacent length. C stands for cosine. Cosine of any angle is the adjacent length over the hypotenuse. And the last one, sine of any angle is the opposite over the hypotenuse. Okay, so just some simple notes that it's important to write down. Remember that to find any unknown angle, you always need need two known lengths. Okay, that means I need to know two lengths in order to find one unknown angle. Or let's say if I want to find an unknown length, if I want to find an unknown length, I need to have one angle and one length. Okay, so this will help us to know how do I, what is the information I need in order to solve unknown problems. Alright, so and also technically in this worksheet, you will see that now the questions become very long word problems. And we usually like to draw diagrams. Diagrams will help us simplify the question to make it easier to understand. Okay, let's look at example 1 now. Example 1, a lighthouse HL is 69 meters tall. Okay, and the point G is on the ground 180 meters away from the foot of L. So if I draw a triangle, I can simplify to this right angle triangle over here. Okay, and therefore the question here is calculate angle HGL. So if I were to highlight, right, angle HGL is this angle over here. How do I find this angle? So let's go back to this here. To find an unknown angle, we need two known lengths. I know this length here and this length here. And this is a right angle triangle. So now I can use TWA, KA, or SO. I must now figure out between TWA, KA, or SO, which one can I use? Okay, so let's identify. Based on this unknown angle over here. Okay, I know that in this right angle triangle, the hypotenuse is the longest side. It's always the longest side opposite the right angle. So I can label that this length GH is the hypotenuse. I label this as hypotenuse. Okay. Now, based on this angle over here, this tells me that this length here, HL, is the opposite side. I label this part as opposite of the angle. And therefore, the last side here, this length, 180 meters, is the adjacent length. I write this as adjacent. Okay. So therefore, based on this angle here, I see that I know what is the opposite side. I know what's the adjacent side, but I don't know what's the hypotenuse. So I can only use over here, opposite stands for O, adjacent stands for A. Okay, so therefore, I can only use the opposite and the adjacent. I check my TWA, KA, or SO. The only trigo ratios that contain O and A is my TWA, TOA. So that means, therefore, now I write my trigo ratio. Very important, I write this as tangent, tan represents tangent of angle HGL is equal to the opposite side. Opposite of this angle here is HL over GL. O over A, opposite over adjacent, it's HL over GL. Okay, then now I can sub in the values. I know that over here, HL is the length 69, GL is the length 180. So therefore, over here, in order to find angle HGL, I will have to take the inverse. So I'll therefore, to find angle HGL, it will be tangent inverse 69 over 180. Then you press this exact value into your calculator. Remember, over here, your calculator, this is a tangent inverse. Okay, so press this in your calculator. And remember, angle is always round off to 1 dp. Your answer should be 21.0 degrees, rounded off to 1 dp. Okay, and this is for example 1. Okay, so I hope that you are clear on how do we solve such questions using trigo ratios. Alright, so now let's look at example 2 now. Example 2, I have a flagpole that is supported by two wires. So over here I have a diagram, two wires AB and AC. Okay, I'm given that this angle is 67 degree, here is 2 meter, AC is 2.5 meters. First, find the length of AD. So over here, I'm trying to find an unknown length. We go back to what I wrote over here. To find one unknown length, I need one angle and one length. So I look at the diagram given. In this right angle triangle, do I have one known length and one known angle? You note that in this right angle triangle here, I have a known length and a known angle. Okay, so therefore, I want to find the length AD. Okay, so if I were to, let me highlight, if I were to highlight this right angle triangle, remember to use Tuaka's rule, I must always have a right angle triangle. Okay, so in this right angle triangle over here, based on this angle here, I know that this length AD is the opposite side. The length AB is the hypotenuse. I label them as short form of O and H. Okay, so based on my trigo ratio, Tuakaso. Okay, my length BD is the adjacent, which I don't know anything about. Okay, but I know what is I want to find the opposite side. I know what is the hypotenuse, I know the angle. So therefore, a trigo ratio that contains opposite and hypotenuse, it's so. Because so over here contains opposite and hypotenuse. So this means that sine of 67 degree. Okay, in this right angle triangle here, the sine of this angle 67 degree is the opposite over the hypotenuse. Okay, so over here, this means that this is AD divided by AB. And now I sub in the values that I don't know. And I know, so over here, AB I know is 2. So therefore, sine 67 degrees is equal to AD divided by 2. Okay, which means that, therefore, to find AD, I'll multiply by 2 on both sides of the equation to get rid of this 2 in the denominator. Therefore, AD is equal to 2 times sine 67 degree. Okay, then press this in your calculator. I will get 1.84 meters. Maybe before I round off to 3SF first, I write as 5SF first so I don't make careless mistakes. Maybe I can write this as 1.84101. Round off to 3SF, it will be 1.84 meters 3SF. Okay, and this is for part 1. Okay, next part. Find angle CAD. Now let me highlight the next triangle I need to look at. Angle CAD is this angle over here. It lies in this right angle triangle. Okay, so over here, I'll highlight this right angle triangle in green. Maybe I'll highlight here in green so I can visualize better. Okay, so I've identified that this is my right angled triangle. Okay, based on this angle here, I highlight in green, This angle is this, maybe I highlight in different color, blue. This angle over here, I want to find what is this angle. Okay, so how do I find this angle here? Okay, in this triangle, I want to find unknown angle. We go back to what we need again. To find an unknown angle, I need two known lengths. So based on this diagram here, to find this angle, I need two known lengths. Based on this diagram now, let me draw it out separately so we can visualize better. Okay, if I were to draw out this diagram now, this is ADC. I know that AC is 2.5. Okay, I want to find out what is this angle here. Okay, this angle over here. I know that AD, I found in part 1. AD, we don't use the 3SF, we use the 5SF answer so that it's more accurate. Okay, so over here, AD is 1.84101 meters. This is 2.5 meters. Now, I want to find this angle here. Based on my Tuakaso again, this is a right angle triangle. I can use Tuaka also. Let's identify. Okay, based on this angle here, I know that my 2.5 is the hypotenuse of the triangle. But take note, even though just now in this triangle you see that AD is now the opposite side, in this right angle triangle, if I were to base on this angle here, DC now becomes my opposite side of the angle, and AD is now the adjacent side. Okay, take note of this difference. AD is the adjacent side now, where DC is the opposite side of this angle. Okay, so over here, based on what I know, the two lengths that I know in this triangle is that I know the length of the hypotenuse, I also know the length of the adjacent side. So A and H, which means I can use the cosine. Okay, so this means that cosine, let me write down part B, cosine, we write short form as COS, cosine of angle CAD is equal to the adjacent over the hypotenuse. So this means that this is AD over AC. Okay, so therefore cosine of angle CAD is equal to AD is 1.84101 divided by 2.5. Okay, so this means that therefore, okay, angle CAD is equal to cosine inverse. Okay, let me shift this triangle. Cosine inverse of, let me make this triangle smaller. Okay. Okay, so over here, cosine inverse of 1.84101, 4101 over 2.5. Okay, so therefore press this in your calculator. Make sure this is a cosine inverse. Your answer to this should be angle 1 dp precision, 42.6 degrees, rounded off to 1 dp. Okay, and this is for example number 2. Alright, let's now look at example number 3. Example number 3 here, I have the height of the building PQ given by 35 meters. HRS is another building, and PH is a sky bridge linking these two buildings together. So this is building 1, this is building 2. Okay, calculate the height of this entire thing over here. So I know that since based on this triangle here, this is a rectangle. Okay, horizontal sky bridge and the buildings are vertical, meaning that this is a right angle triangle. Okay, this means that HS here is also 35 meters. Okay, so over here, now I need to find the length of RH. RH is a question mark. I don't know what is this length, I need to find it. Okay, but over here, I see that in this right angle triangle here, I only know one angle. In order to find one known length, I need one angle and one length. So that means I probably need to find what is the length of PH. And to find the length of PH, I need to look at this triangle over here. Okay, this triangle over here, I know that based on this angle here, 18 degree, okay, maybe highlight this angle here, 18 degree, okay, and I highlight this triangle, okay. In this triangle over here, I can see that over here, based on this angle 18 degree, my HS is the opposite side, my PH is the adjacent side, okay, and PS is the hypotenuse. Okay, so over here, in order to find the adjacent side, I write out my tuakaso again. Tuakaso. I know the length of the opposite. And I want to find the adjacent side, which is here. Therefore, I will need to use the tangent. Okay, so over here, this means that, let me write down, tangent of 18 degrees is equal to the opposite, which is HS, over adjacent side, which is PH. Okay, then from here, I now continue to simplify and sub in the known values. Tangent 18 is equal to HS, which is 35, over PH. Okay, so therefore, how do I find the length of PH? Over here, we can simplify this step by step. Okay, to get rid of the fraction, I multiply PH on both sides. So PH times tangent 18 degree is equal to 35. Okay, therefore to find PH is equal to 35 divided by tangent 18. Okay. Then over here, I can calculate my calculator to 5 SF. This is 107.72. Okay. Now I know the length of PH now. I want to find the length of RH in this right angle triangle over here. Okay. So what can I do? Now I look at this right angle triangle. Okay. Let me highlight this in green. In this right angle triangle over here, I want to find the length of RH. Based on this angle here, I write in a different color. I can see that I use black. RH is the opposite side. Based on this angle here and this triangle, RH is the opposite side, PH is the adjacent side. So different triangle with different labeling. RH is the opposite side, PH is the adjacent side. Okay, so based on my tuaka so again, I know I want to find an unknown length. I know the angle. I know the adjacent side. I want to find the opposite. So O and A, I'll use tangent again. I'll use tua. So this means that over here, okay, tangent. Now in this right angle triangle in green, okay, tangent 48 degrees is equal to RH, the opposite side of this angle in this right angle triangle, over PH. Then I submit the known values. Tangent 48 degree is equal to RH over PH, which I found earlier, which is 107.72. Okay, which means that, therefore, to find RH, I'll multiply 107.72 to both sides of the equation. RH is equal to 107.72 times tangent 48 degree. Okay, then you can press this in your calculator. You should get, don't round off to 3SF yet because this is not the final answer. You should get 119.64 meters. Okay, so therefore, final answer, to find the height of the building. Therefore, height of building, which is the length of RHS, this is equal to RH plus HS. This building here is the length of RH plus HS. Okay, RH is this, HS is 35. So therefore, this is equal to 119.64 plus 35. Okay, which will give me 154.64. Now I can round off my final answer to 3SF. I should get 155 meters, rounded off to 3SF. Okay, and this is the solution to example 3. Let's look at example 4 now. In example 4, I have level A and B are two different levels on a vertical building. So this is the vertical building over here. And point D is 50 meters away from the foot of the building point C. And this angle here, CAD, is 47 degrees and BDC is 27 degrees. So find distance AD. So over here, AD, you can see that it's part of this big triangle. So I'll use a highlighter to highlight this big triangle over here. Okay, and we know that clearly triangle ABC is a right angle triangle. Label this over here. So therefore, the right angle triangle, I can use my tuaka so. Okay, so over here, based on this angle given, 47 degree, we can identify that, let me label, okay, AB is the AD is the hypotenuse, it is the longer side of this triangle, opposite the right angle. DC, based on this angle over here, DC is the opposite side, and AC is the adjacent side. Okay, so I want to find the unknown length. I got one angle, I also got one length. So I want to find H, I got the opposite length, OH, which means that I have to use so. Okay, so over here, this means that sine of the angle 47 degree in the right angle triangle, highlighted in yellow, is equal to the opposite side, DC, over the hypotenuse AD. Okay, DC over AD. Then I submit the known values here. Okay, sine 47 degree is equal to DC, which is 50, over AD, which is unknown, and I want to find. So therefore, this means that to find AD, I first multiply by AD to both sides to get rid of the fraction. So this means AD times sine 47 degree is equal to 50. Okay, so this means that AD is equal to 50 divided by sine 47. Sine 47 degree. Press this in the calculator. You should get 68.4 meters, rounded off to 3SF. Okay, and this is for part A. Let's now look at part B. To find the distance AB, this means that I need to find the length of AC minus the length of BC. Okay, so over here, let's start with the small triangle first. Maybe I highlight this triangle in green. Okay, in this triangle here, how do I find the length of BC? Okay, so over here, in this triangle, to find the length of BC, I got this angle over here. I will highlight this in black. I got this angle over here. Okay, in this triangle here, which means that BD is the hypotenuse, DC is the adjacent side and BC is the opposite side of this angle. Okay, so I want to find the opposite side here. I know the adjacent side. I have to use 2. Okay, I hope you can see that I got O and A. I must use 2. So that means that for this part here, okay, tangent of angle 27 degree is equal to the opposite side BC over 50, the adjacent side, which is BC over DC. Okay, therefore I continue. I know that tangent 27 degree is equal to BC is the length I want to find. DC, I know that the length of DC is 50. So therefore, BC, I multiply by 50 to both sides of the equation to get rid of the fraction. This is 50 tangent 27. Okay, press in your calculator, you should get 25.476 degree. Okay, this is, oh sorry, this is not degree, this is a length. This one should be meters. Okay, 476 meters. I write in 5S because 5SF because this is not my final answer yet. Okay, next I found the length of BC. Now I want to find the length of AC. Okay, so over here AC lies in this right angle triangle here. Okay, I know that from this right angle triangle, I know the opposite length. I want to find now the adjacent length. O and A, I should use tangent as well. So this means that based on this angle 47 degree, okay, tangent 47 degree is equal to the opposite length DC, the opposite length DC, which is 50, over adjacent length, which is AC. Adjacent length over here is AC. Okay, so this means that AC times tangent 47 degree is equal to 50. So therefore, AC is equal to 50 divided by tangent 47 degree. Okay, then press in your calculator, you should get 46.626. So therefore, now I know the length of BC and AC. To find the length of AB here, I want to take AC minus the wavelength of BC. Okay, so over here, very simply, to find the distance AB is simply equals to AC minus BC. AC is 46.626 minus 25.476. Pressing this in your calculator, your final answer round off to 3SF should be 21.2 meters rounded off to 3SF. Okay, and this is for example number 4. Alright. Let's now look at the last example, example number 5. Okay, example 5, a ladder of length 12 meters. So the ladder leans against the top edge of the window and forms an angle of 60 degree. So the ladder is this AP here, length 12 meter, form angle of 60 degree. Okay, then after the ladder leans against the bottom edge of the window, here BQ, then the angle becomes 48 degree. Find the height of the window, meaning that this part here, PQ, is the window. Okay, I want to find this length here. So in order to find this length of PQ, obviously you can see I must find the length of PR minus the length of QR. Okay, so let's do it step by step. Maybe I start by the big triangle first. The one that have 60 degree angle, I highlight in yellow first. This triangle over here. Okay, I want to find the length of PR. How do I do that? I know that AP is the ladder. This is the ladder, lean against the top edge of the window. This AP length is 12 meters. Okay, this angle is 60 degree. And I want to find, based on this angle, this side here is the opposite side. H is the hypotenuse. Okay, so I'll label over here clearly. PR, here is the opposite side. AP here is the hypotenuse. Okay, so by my tuaka so again, I have to identify tuaka so. I want to find the opposite side. I know the hypotenuse. I have to use so. So this means that sine 60 degree is equal to opposite, which is PR, over the hypotenuse, which is AP in the yellow triangle. And I know that AP is equal to 12. Okay. So therefore, PR is equal to, multiply 12 on both sides, it will become 12 sine 60 degree. Press in the calculator to 5SF, I should get 10.392 meters. Okay. Next one now, I want to find the length of QR. QR is part of this other triangle over here. I will highlight this triangle now in green. Okay, so I highlight this triangle now in green. Okay. Okay. This triangle now is highlighted in green. I know that for this triangle, I use black to write. This length here, BQ. This length here is the hypotenuse. I know that this is the ladder. This ladder length is also 12. Okay. This length over here is QR, which is the opposite length. Okay. So based on this green triangle, again, I want to find out what is this opposite length. This length over here. I know that this length here, the hypotenuse, is the ladder length, which is 12 meters. I know that this angle here is 48 degree. So I know the opposite. I want to find the opposite. I know the hypotenuse. I have to use so again. So this means that sine 48 degree is equal to QR over BQ. Okay, and I know that over here, sine 48 degree is equal to QR, which is what I want to find, over BQ, which is the ladder length, which is 12. So therefore, QR is equal to 12 times sine 48 degrees. You can press this in your calculator as well. Okay, you should get, round off to 5SF should be 8.9177 meters. Okay, so last step. Therefore, to find PQ, this length here is the length of PR minus QR. So this is PR minus QR. We found the length. PR is 10.392 minus away 8.9177. Okay, so final answer round off to 3SF, you should get 1.47 meters. So since I know that this length over here is 1.47 meter, you can conclude that, therefore, height of window is 1.47 meters. Okay, to answer the question. Okay, and this is for example 5. Alright, so once done, you can now move on to the assignment questions and as well as your practice questions in your workbook. So please complete these questions over here by the following Monday for submission. Okay, I think there are questions in this worksheet to complete here. These 3 questions here together with the workbook questions assigned over here. Okay, and this will be the end of this video.